Alright, hello, my name is Richard, and today we're going to be going over some math problems as they've been posted on the OneClass website. If you need any more homework help or any personalized tutoring, please be sure to check out the links in the description below. So let's get started with our problems for today. So the first question we'll be going over says 4 points are always coplanar if A, they lie on the same plane, B, they lie on different planes, C, they lie on different lines, or D, they lie in the same plane. So the first way to tackle this problem would be, so there's two ways. First, you can just kind of deconstruct the word coplanar. So what does the word mean, right? So whenever we see a prefix co, what we like to think of is the same. So normally you think of collinear, coplanar. All of those words have the co-prefix in it, meaning that these two or three or four, however many things, are either on the same line. If it's collinear or coplanar, they're on the same plane. That kind of already answers the question, meaning that the answer choice would be D. But just looking at the word, we have the root of the word here, planar, meaning plane, and the prefix co. So once you actually deconstruct the word, you can get the answer pretty quickly. So the answer choice for this problem is D. Just to look at the written response here, yeah, basically the same thing that I've said, exactly the same thing that I've said. So let's just write that this solution is good. Great job. All right, and that is the first question. All right, so moving on to the next question, we have for what values of m does the graph of y equals mx squared minus 5x minus 2 have no x-intercepts? So let's first of all write out our equation, the graph, and when we're considering any sort of parabola, we know that we can factor parabolas that have x-intercepts, or in this case, I'm going to say, I'm going to interchangeably use the word roots because the roots of a parabola are the x-intercepts. Whenever we have any roots of a parabola, normally we can deconstruct the parabola into factors of these roots, right? So x minus a is one factor, and a is a root, right? So how do we find these roots in most cases? Well, in most cases, what we do is we just set the equation of the parabola equal to 0. So let's do that because we want to find at what x values we're going to have a y value of 0. And that's basically what a root is, right? So if you think of a parabola that intersects maybe these 2 points right here where the x's are, these are the roots of the equation, and normally it is where y is equal to 0. So where y is equal to 0. And in order to solve this, we could turn to the quadratic equation. So the quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So whenever we have a parabola set equal to 0, or a quadratic equation for that matter, we can use the quadratic equation here where a, b, and c are these coefficients of our quadratic equation respectively right here. So a is m, b is negative 5 because we have to take that minus sign into account, and c is negative 2. So plugging in for our a, b, and c, we get 5 plus or minus, well, let's take this slow, so negative minus 5 plus or minus the square root of minus 5 squared minus 4, and a in this case is m, c is minus 2, all over 2a is m. And in this situation, where we want to think about when we don't have any x-intercepts or any roots. The case of having no roots is when this quadratic equation right here can't be solved, right? So we have to see what part of this equation would make it unsolvable, or at least give us a, let's say for example, an imaginary solution. And me saying that already kind of gives it away. We know that whenever we take the square root of x, I'm going to use a different variable actually to be less confusing. Let's say we have some sort of number a, and we know that a is less than 0, then we know that the square root of a is imaginary. So in this situation, we want to find if we kind of take what we know here and apply it to the square root in the quadratic equation, we have to make sure that what's inside of the square root is less than 0, because then we get an imaginary root, or sorry. Oh, my headset just died there. Uh, I see what the problem could be. Okay. All right. So this should prevent it from dying. Okay. So we know that the square root of a has to be less than 0, and in this case we're going to say that our a is going to be what's inside of the square root. So we have to make sure that what's inside of the square root is less than 0. So we're going to rewrite, but this time in a more simplified form. So minus 5 squared is 25, and then minus 2 times minus 4 is plus 8m is less than 0. So this is our a, and it has to be less than 0. We could solve this inequality by subtracting 25 on both sides. So we get 8m is less than minus 25. And then if we divide by 8, we get m is less than minus 25 over 8. So this is the inequality, and this is the constraint that we have on m. So m has to be less than minus 25 over 8, and then we will have no x-intercepts for this quadratic equation. So that's what the answer is. So just looking at the written response here. Yep, this is exactly what I've done, and yet this is exactly the answer. So I'm going to write that is the correct solution. Good job. And the solution is correct. Okay. All right. Moving on to this next question. We consider the quadratic function f of y is equal to 8y squared minus 7y plus 6. And we want to know what is the constant term of this function. Okay, so simple enough of a question. Whenever we have any sort of quadratic function, so let's write a general form of a quadratic function, and I'm going to use variable x in this case. So if we have f of x is equal to ax squared plus bx plus c. So our coefficients here, a, b, and c, they are just any coefficients that you like. And in this case, we have to differentiate our coefficients from our variables. So these right here, so these x values right here are variables, while a, b, and c are coefficients. Now, what a constant is a number that is by itself and doesn't rely on any variable, right? So for example, if we look at the ax squared term right here, we see that this entire term relies on the value of x, so it's not constant, it's always changing as x changes. Same for this bx term. However, if we look at c over here, c will always take the same value no matter what the value of x is. It is not dependent on x. So for that reason, we call c our constant. All right. Going back to the original question, we see that in our quadratic equation, we have three terms. We have 8y squared, we have minus 7y, and we have 6. So two of these terms do rely on y and always change with y. So that's these two terms. So the one term that is always the same, no matter what value of y you plug in, is this 6. So we could say that 6 is the constant term of our function, and that is the answer to the question. So in terms of the written answer, we see that that is correct. I basically gave a more complex explanation, so that is the correct solution. Good job. Alright, and that concludes this question. Okay. So, next question. What number would you add to both sides of x squared minus 20x equals to 5 to complete the square? So the first thing I like to do is I just want to put this into a nice quadratic equation, so I'm going to subtract by 5 on both sides. So x squared minus 20x minus 5 is equal to 0. Now, what does completing the square mean? So let's say we have some sort of number a, right? Completing the square means we want to get this quadratic equation in the form either x minus a squared or x plus a squared, right? Get it in either one of those forms. Oh, actually, I'm sorry. We would just want to get it into, yeah, we want to get into both these forms, my bad. So, the reason why I just went back a little bit is because we have to choose which of these forms we want based on the signs of our quadratic equation. So whenever we have two minus signs here, that means that the two non-quadratic terms in our quadratic equation will have negative signs, and they do have negative signs, so we have to choose this form right here. So now we just have to find a value of a that will satisfy this, right? So if we expand out what x minus a squared actually is, we get x squared. So let's actually just write this as a product, like so. And then we could FOIL these together, and we would get x squared minus ax plus a squared. And then we just write this as x squared minus 2ax plus a squared. Alright? So having this, we can now compare this to the quadratic equation we have. So x squared minus 20x minus 5 equals 0. So if we can only add a constant term to both sides, right, so a number, because we can only add a number to each side, we know that these two terms are going to stay the same. So let's find the value of a like it is in our expanded form of x minus a squared. So I'm going to set minus 20x equal to minus 2ax. I'm going to divide both sides by x, get rid of that, and I'm going to divide both sides by minus 2 and get a 10 left over. So that means in our example here, a is equal to 10. Now with a being equal to 10, we can now find what our value of a squared should be. So so a squared is 10 squared, which is just 100. So we need our quadratic equation to be, copying this form right here, x squared minus 2 times 10x plus 100. So x squared minus 20x plus 100. However, we currently have x squared minus 20x minus 5. So how do we get from this equation to this equation? We just add 105 to both sides, right? So I know I'm jumping between equations here, but this is our original. If we add 105 to both sides, we get our desired equation. Oh, I'm sorry. Did I say to... Okay. Yeah. So that should be minus 100. My bad. So I apologize for the confusion here. So we want to have minus 100 here, right? Because we have... Oh, wait, no. We're fine. What am I talking about, right? So we get this. Um, yep, everything is fine. So we get that, and we have to add 105 to this side as well. Okay? And then we can put this in our x minus a squared form, and we get x minus 10 squared is equal to 105. So just ignore when I went back there. I thought I got the signs wrong, but obviously I didn't. I should have just kept following through. This would be our correct answer here. By adding 105 on both sides, we get 100 on the left-hand side and 105 on the right-hand side. But we do end up completing the square here, which is the result. I apologize for the headset dying. I need to fix something. Okay, there we go. That should be fine. Okay. So this is our correct answer, and let's just look at the result here. This is correct, exactly what I have, so this is the correct solution. Great job. Alright, and that concludes this question. Okay, so our next question. We have a function, f of x is equal to 3 times 16 to the 3/4 x. I'm guessing that's what that says. It's a little hard to see. And we have 6 statements, and we want to see if all of these are true or not. So we're going to go through each statement one by one. So our first statement is the initial value is 3. So the initial value being 3 basically means that f of 0 is equal to 3. So we need to prove this. If this is true, then the statement is correct. So by plugging in 0 into this equation, we get 3 times 16 to the 3/4 times 0, which is just the 0, right? Because any number times 0 is 0. Now, whenever you have any sort of number raised to the 0 power, so any number a raised to the 0 power, that's always 1. So we know that this term is equal to 1. So it would just be 3 times 1, which is 3. So f of 0, the initial value of f is equal to 3. So this is correct. All right. Our next statement. The initial value is 48. So since we already found that the initial value is 3, right? So we know that it's 3, then that implies that it's not 48, right? So that would be incorrect. Okay? And now we have the next statement. The domain is x greater than 0. So this statement is incorrect, and I'll explain why. So the domain is all x such that f of x exists, right? So all values of x where you get a defined value in the function. So to prove this case wrong, that the domain is greater than 0, let's plug in, for example, -1, right? So if we evaluate the function at -1, we get 3 times 16 to the -3/4 power, right? This is still a defined function because I believe it would be 3 over 8 because you would just do the 4th root of 16, which is 2, raised to the 3rd is 8, negative power, so it's 1 over 8. 3 times 1 over 8 is 3 over 8. So because the function is still defined, and you are allowed to take negative exponents, right? Negative exponents are a thing. They give you defined numbers. So for that reason, the statement is incorrect, because you can take basically any number, and you can raise it 16 to that power, and you will still get a defined number, even 0, as we did in the first statement. So this one is incorrect. Okay. And now we look at the range. So the range is y greater than 0. So how do we tell that the range is y greater than 0? So again, the range is all values of y, basically. So the values that y spans, right? So when you look at the values that y span, as you plug in any x value, there's one thing that they all have in common. So f of x is equal to 3 to the 16 times 3/4 to the x. So for any value of x, for any exponent that this takes right here, this entire term will always be positive, no matter what, right? Because what's inside, what the base is right here is positive. The exponent of any positive number raised to an exponent is still positive. And multiplied by this positive number will also still be positive. So y will always be positive, that's known for a fact. And y will also never be 0, because this number is non-zero, this 3 coefficient, and this, you can never raise any base to an exponent and get 0. So this will never be 0. So for that reason, we can conclude that f of x is always going to be greater than 0, meaning that our statement is correct. Okay? So now we have statement E. Statement E says the simplified base is 12. Statement F and E actually go hand in hand, right? So we're looking for the simplified base. So to simplify the base, what we can do is look at the base that we're simplifying. So 16 to the 3/4 x, right? And we want to simplify this base as best as we can. We can use properties of exponents, and we can say that this is the same thing as 16 to the 3/4 to the x power, because whenever you raise an exponent to an exponent, you end up multiplying them, and 3/4 and x in this case are a product. So now we just evaluate 16 to the 3/4, and whenever you have a fraction exponent, what you do is you take the fourth root of, so the denominator acts as your nth root. So an n denominator gives you an nth root of your base. So you would take the fourth root of 16, and then your numerator would be the exponent. So to the third power, and then this entire thing raised to the x power. And now we have to ask ourselves, what number, when you raise it to the fourth power, gives you 16? Pretty quickly, you can come up with the number 2. So the fourth root of 16 is 2. That would be cubed to the x power. And finally, 2 cubed is 8. So you would get 8 to the x power, meaning that our simplified base right here is 8. So because our simplified base is 8, we say that E is incorrect. And we say that F, where the statement says that our simplified base is 8, is correct. So just to recap, that would be correct, 2 incorrects, correct, an incorrect, and a correct. You can go through this as well and just see what the written response is. So correct, 2 incorrects. They're giving the right justification as well. Yep. And yep. Okay. That's good. So we say solution is correct. Great job. All right. And that's correct. Okay, so moving on to our next question. Which equation represents an exponential function with an initial value of 500? Okay, so we're going to go through all of these one by one and say whether they do or they don't represent an exponential function with an initial value of 500. So for the first answer choice, we have 100x to the fifth. So what an exponential function with an initial value of 500 means is that f of 0, our initial value, has to equal to 500. Okay? So if that is true for this case, right, so this is f of x, if that is true for any of these cases, then its initial value is 500, and that is the correct answer. So we're going to find f of 0 of this term, so you're going to have 100, and then plug in 0 for x here, so you're going to have 0 to the fifth power, and you're going to get 0, because anything times 0 or raised to a power of 0 gives you 0. So this is not 500, so it's incorrect. Now we're going to look at the second equation. So, sorry, I got that wrong. So 5 to the x power is equal to f of x. So we want to plug in f of 0 again, or x equals 0 in this case. We get 100 times 5 to the 0th power. And one second. Okay. And as we've discussed previously, anything raised to 0 power is 1, so you just get 100 for this case. Okay? So you get 100, and then that is not 500, so you reject this answer. Now for answer choice C, you have to consider f of x is equal to 500 x squared, and we're going to plug in x equals 0 again and get 500 times 0 squared, and that is equal to 0. And 0 does not equal to 500, so incorrect again. Our last choice should be the correct one, but let's just make sure it is. So we get f of x is equal to 500 times 2 to the x, and we want to solve for f of 0 once again, and we get 500 times 2 to the 0th power. Anything raised to the 0th power is 1. We get 500 times 1, and then we get 500. So because f of 0 is 500, the initial value of d is 500, and that is our correct answer. So in this case, we would go with D, and this is the same thing that I've done here, systematically proving that D is correct. So this is the correct solution. Good job. All right. Okay, so next question. Ray CE is the angle bisector of ACD. So let me just actually draw this diagram out here. So we're going to have A, we're going to have B, C in the middle here, and then D coming out like this, and E coming out here. Okay. And we're asking ourselves which statement about the figure must be true if CE is our bisector. Okay. So that says bisector. So what a bisector does is it splits up any angle in exactly half. So in this case, it's the bisector of angle ACD. So we want to ask ourselves, what is the result of this bisector? So the result of this bisector is that these two angles right here are going to be equal to each other. So I'm going to write an equal sign next to them. These two are equal to one another. So angle ACE is equal to angle ECD. Okay? Another thing that we could say is that both of these angles sum up to angle ACD, right? Because they've been bisected, now they're two parts of a whole. But we could say that when we add them together, we get the whole back. So we could say angle ACE plus angle ECD is equal to angle ACD. Okay? So now that we have this statement, we can substitute in the value for one of these. So let's say arbitrarily we choose ACE. Because they're equal to one another, we can substitute it in for ECD, and we can get one of the statements that we actually have here, which is statement 2. So just to show you what I mean, we have angle ACE plus angle ACE is equal to angle ACD. Okay? And that means that we have 2 of angle ACE, um, the product of 2 of them, equaling to the angle ACD, which is exactly our answer choice B in this case, right? That's just a consequence of an angle bisector. And just looking at some of these other answer choices and explaining why they're wrong, if we see that 2 of angle ECD are equal to ECB, so that would only be the case if we knew that that DC was a bisector as well. But because the problem doesn't state that it's a bisector, we can't assume that it is. So for that reason, we don't know if it's true. So we can't say it's true. So B is true. Angle ACE is equal to DCB. So again, we don't know what the value of DCB is, right? So because we don't know that, we can't, and the only way for C to be true is if all 3 of these angles are equal as well, right? Because if ACE and DCB, so I'm actually just going to call these angle 1, 2, and 3 respectively. So if 1 and 3 are equal, and 1 and 2 are equal, then 1 and 3 are equal, meaning all of them have to be equal, which we don't necessarily know that being true. So C can't be true. And then ECD is equal to ACD. ECD is equal to ACD. Well, no, because ACD is just the whole, and ECD is that half of the whole. So they obviously can't be equal. And 2 is the correct option here as well, and the work is the same thing that I've done here. Yep, so that is the solution. Great job. All right. Okay, so let's move the last problem up a little bit. So now we're going to find the area of the part of the plane 5x plus 2y plus z is equal to 10 that lies in the first octant. So we're going to have 5x plus 2y plus z is equal to 10. And we want to find the part of the plane that's in the first octant. So if we think about what the first octant looks like, right? The first octant, really there are 8 of them, but if we think about the first octant, it would be this area that we're used to seeing whenever we look at a 3D Cartesian plane, and it would be this little cube right here. Not so this would be the other octants behind it and under it, right? But we don't want to consider those. We just want to consider everything that is in this area and going up, right? So that is the octant that we're considering. Okay, and that means that we have some certain constraints. So we know that x is going to be greater than 0. We know y is going to be greater than 0. And we know that z has to be greater than 0. Okay, so firstly we should, before we know we're eventually going to be integrating, and we want to put this equation here into a form that we can integrate. So we want to put it in a form of a function of x and y. So by subtracting 5x and 2y on the left side to the right, we get z is equal to 10 minus 5x minus 2y. Alright, so this is basically our f of x, y, and we know we're going to be integrating with respect to x and y. So we also have to come up with our bounds. So for this case, we want to set one of our bounds to be constant and one of our bounds to be variable. depending on the other variable. So let's say our x is constant, right? So if our x is constant, then in order to suffice this, and in order for z to be greater than, or I guess it's greater than or equal to 0, right? Because if we are at this point here, it's still in the first octant. So greater than or equal to 0, to suffice this condition, we have to say that x is an element from 0 to 2, right? So these are the bounds on x. And then when y is going to be our variable, we can say that y ranges from 0 to a function of x. So it ranges from, let's say we were to write this as, I'm running out of space here, so 0 is equal to 10 minus 5x minus 2y. So this is the line representing how y varies. If we are to add 2y to this side and divide by 2, we would get y is equal to 5 minus 5 halves x. So this is y as a function of x, and this would be how y ranges. So these are the bounds. Now, whenever we're talking about a surface area of a plane, um, there is a certain equation or a certain integral form that we use. So just to make sure, so let's say this is our surface. Normally, I believe it is the partial derivative of x squared plus the partial derivative of, well, hold on, I'm sorry, one second. So it's the partial derivative plus, with respect to x, partial derivative with respect to y plus 1, and then over your surface. So let me just make sure here. So that is how it's done in this case. And also, we want to define what our partial derivatives are. So in this case, this is our function f. So the partial derivative with respect to x would be the derivative of minus 5x. You treat the other terms as constants, so it would just be minus 5. And our partial derivative with respect to y in this case would be minus 2, because you treat this as your variable term and these two terms as your constants. So you would get minus 2 in this case. All right. So plugging these values in, we get, so first let's put our bounds. So we want to integrate over the variable bounds first. So 0 to 5 minus 5 halves x, 0 to 2, and then we know we're going to have dy first and then dx, right? So we are going to plug in f of x. We're going to get square root of minus 5 squared, and then our partial derivative with respect to y is minus 2, so minus 2 squared, and then plus 1. So we're going to rewrite our integral here. So we know that this is going to be square root of 30, and because square root of 30 is a constant term, we could take it out of the integral, and let me just make some space here. We could take it out of the integral, and we can differentiate with, not differentiate, sorry, integrate with the same terms here, and we're just going to be integrating 1 with respect to y and x. So after integrating with respect to y, we get 0 to 2. The integral of 1 with respect to y is just y. And we get 0. Our bounds are 0 to 5 minus 5 halves x. And now, because we have a 0 bound here, we only evaluate our upper bound. So we get 0 to 2 of 5 minus 5 halves x dx. So our integral is pretty simple here. So integral of 5 with respect to x is 5x. Integral of 5 halves x is 5x squared. Oh, I'm sorry, it's minus 5 over 6 because, wait, nope, it is, it's 5 fourths, my bad. So it's minus 5 fourths x squared, all right? That should be it. And then we're going from 0 to 2. So at 0, the whole thing is 0, so we only evaluate our upper bound. So we get 10 minus, here x squared is 4, so we get 5 times 4 over 4. These 4's cancel. We get 10 minus 5, and that gives us 5. And let's not forget that we had the square root of 30 on the outside here. So if we carry it over through all of our computations here, we add that square root of 30 here, and we get that our answer is 5 times square root of 30. And that is what was gotten here. And then in terms of units, yeah, this written response here has units squared. I'm guessing, yeah, it would be in terms of units squared. Okay, so that is the correct solution. Good job. All right. Now, which are the solutions of x squared? Okay, so it's a little hard to see what it is here, so I'm just looking from the solution. So x squared is equal to minus 5x plus 8. So first of all, if we are looking for the solutions, so the values of x that solve this quadratic equation, we are essentially looking for the roots. Sorry. So we want to first get this in a situation where it's equal to 0 in order to find the roots. So we're going to add 5x on both sides, and we're going to subtract by 8 on both sides. So we're going to get x squared plus 5x minus 8 is equal to 0. Now that we have this, we can apply the quadratic equation, which we know it as x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, our a, b, and c are the coefficients of our terms in the quadratic equation. I'm putting this 1 here because if there's no coefficient, there's always an invisible 1 right here. So that's our a, that is our b, and this is our c. Okay? So we're going to plug them in. So in this case, our b is 5, so we're going to get negative 5 plus or minus, and then we're going to have b squared, which is 5 squared, which is 25, minus 4 times 1 times c, which is minus 8, all over 2 times 1, so just 2. So we can write this as minus 5 plus or minus the square root, and then we know minus 4 times minus 8 is 32. 25 plus 32 is 57, and that's over 2. So this is essentially our solution. We have two solutions. The quadratic equation gives us both roots, and you would get the first root by taking this plus or minus to be a plus, and the second root by taking it to be a minus. So these are the solutions, and the same thing was done here, I'm guessing. Yep. So that is the correct solution. Good job. All right. That concludes this question. Okay, so how do I solve for c when finding the equation? So let's look at this equation here that they have. Okay, so right here we have a parabola, and we have this equation of a parabola here that he is using in order to get it, where he takes the vertex, or he or she, not, and then they take the vertex and they plug it in here. So first of all, let's just go over the equation of a parabola, the standard form. So for a vertex a comma b, right? So any vertex of a parabola, we could say that the equation of that parabola is y minus, y minus b squared equals to 4p times x minus a squared. Okay, so in this case, he or she has a c instead of a p, that's fine. For this example, I guess I can get rid of this p and use a c. And we want to find how to find this value of c. Well, first let's plug in the value of the vertex that is in this parabola. So the value of the vertex is minus 5 minus 5 comma 4. Okay, so this being the x value, this being the y value. So we're going to plug them in respectively for being a and b as our vertex, and the standard form is going to look like this. So we're going to have y minus 4 squared is equal to 4c times x minus negative 5, which is x plus 5 squared. Now, the question, how do you find c? You find c by taking any other point on the parabola and testing it and seeing what the value of c would be. So a good point here to take would be, for example, this intersection of this line and parabola. So that's minus 4 comma 6. So test minus 4 comma 6. And by doing so, we're going to plug in 6 for our y. So we're going to have 6 minus 4 squared. 4c, we don't know c, that's what we're looking for. And then we're going to have x plus 5 squared. X in this case is minus 4, so minus 4 plus 5 squared. And we're going to get 2 squared is equal to 4c times 1 squared. And then 2 squared is 4. 1 squared is 1 is equal to 4c. And we're going to get that c is equal to 1 ultimately. So we solve for our value of c. And because this point holds on any arbitrary point, it's also going to hold on this vertex. That's just something that we know. Alternatively, we could have tested it on this point right here, which is another obvious point right here. So that's minus 1 comma 0. We probably could have tested on that point as well, but this looked like a much easier point, and we will still end up getting the same value of c. So ultimately, our final equation of the parabola is going to be 4 times c, which is 1, so I'm just going to leave it as 4, times x plus 5 squared. So this is it right here. And so this person also recommended to use the same point and get the value of c. So after plugging in x comma y equals minus 4 comma 6, we solve for c and get c equals 1. Good job. All right. Okay. And that is all the questions that we have for this session here. So I'd like to thank everyone for watching. And once again, if you need any more help, homework help, or tutoring services or anything like that, please check out the links in the description. Thank you and have a great rest of your day.